Welcome back. So you made it. This is going to be the last lecture from IR chapter, and we want to go after how to differentiate the different compounds of amine. Do we have two hydrogen or one hydrogen attached to nitrogen? Or maybe we don't have actually H attached to it. But first, let's go after the meaning of primary and secondary amine. So if you, let's say, you have R, and R is going to be the alkyl group. It can be anything, okay? So let's say we have R group attached to nitrogen, and nitrogen has two hydrogens, okay? In that case, we say nitrogen, it will be primary. And you can show it by 1 and put 0 there, okay? And that's going to be a primary. And so one example for it, it will be CH3 and then NH2. Okay. Or how about this? You go R attached to nitrogen and okay, another R, and we have only one hydrogen. And of course, each nitrogen, it has one lone pair. Okay, this nitrogen, this amine is gonna be secondary. Okay. And so we have primary and secondary, and how about this? Okay. We have R, okay, forgive me, R attached to nitrogen, and then another R, and we do have a lone pair, and that's going to be tertiary. Okay, tertiary amine. Okay, and you can write the same thing for alcohol. You can say, and for example, carbon that has 3 hydrogens, and say here we have an OH. Okay, right. Or here, this is gonna be a primary alcohol. Then you say R attached to carbon, attached to R, and here we have hydrogen, and that's gonna be OH. This one, it will be secondary alcohol because OH, or the functional group for alcohol attached to carbon, that is attached to 2 more carbons. And last one, you have R attached to carbon, attached to R, another R, and here we have OH. That's gonna be a tertiary alcohol. Okay, I want to go after this two, okay, and see how I can differentiate those two amines from each other. Okay, and if you have a primary amine, because you have 2 hydrogens attached to nitrogen, you will get 2 signal. Okay, one hydrogen, let's say, is getting far from nitrogen, and the second is getting close to it. Okay, or it can happen like that way. Okay, or both are getting far, getting close. So that's one type of, for example, stretch. Or how about this? Well, this one's getting far, the second one is getting close. So we have a symmetrical. Okay, these two are running same direction at the same time. Okay, or opposite. And that's the reason I see 2 signals, 2 signals there. So if you see 2 signal, forgive me, if you see two signal for, or like for 2 signal here close to each other in a range of between, let's say, 32 to 3300, and usually they have like kind of a narrow shape, and that's a sign that you have NH2. Okay, and if you see only one peak there, in that case, I'm gonna say there is only one H, and this is gonna be a secondary alcohol. Sorry, secondary amine. And while the first one was primary. Okay, and again, what's the reason for getting 2 different signals when we have a primary? The reason for it, and you can have two hydrogens getting far from each other, like technically they are moving, far from, okay, this nitrogen, and assume those are hydrogens. Or you can get an asymmetrical stretch. This one is getting far while that one is getting closer, and so you get 2 types. Okay, AC and symmetrical, stretch, and those two, they will show up in two different actually region, or they will require two different frequencies or wave numbers. And I have two spectrums here, okay, and I'm gonna go try to match them, okay. And first thing, as usual, here we have carbon attached to hydrogen. This is going to be sp3. Okay, where is the 1500? The 1500, it will be somewhere here. Okay, somewhere there. So clearly I have carbonyl. Okay, let me work on it in my good note. Okay, so I'm going to highlight the 1500. This is the 1500. Okay, and I see a peak here, one there, another peak here. So I'm going to say I do have a CO bond, okay, a double bond, okay, double bond of CO. And so I do have carbonyl. And next we said that's going to be CH with sp3 hybridization. Okay, so CH with sp3 hybridization. Okay, I see a narrow peak and a single one there. That can be NH, and it's gonna be technically a secondary amine. That means I have two R's attached to nitrogen. Well, here I have two peaks. One is there, and that's gonna be the second one. So I can say that can be NH2. Okay, we have NH2. Okay, but clearly we have carbonyl groups there. And so if I want to match them with the structure that I've been given, I can say this is going to be number 2, and that one is number 1. And the reason for it, again, we have one hydrogen there, and that hydrogen is going to show up here. That one has 2 hydrogens. One is here, and that's the second. And I can see one peak here, and that's the second peak there. And so number 1 represent like the molecule that I label it number 1, and it's gonna be the first spectrum, and the molecule that I label it the 2 represent the second spectrum. Okay, so this one. That's going to be this molecule, and that one, it will be that molecule. Very good. Okay, so from like IR, okay, from IR and spectroscopy, I can say this: find the 1500, okay, find the 1500 line and try to, look to the region that is higher than 1500. Okay, if you see a peak around 16 to 1800, you have a double bond. Okay, double bond of carbon, say X, carbon O, carbon oxygen, carbon nitrogen. And if you see a peak around 21 to 2300, then you have a triple bond. Okay, triple bond between carbon and another carbon, or maybe carbon nitrogen, it can be. And if you see a peak between 27 to like 27 or higher, then you have an hydrogen attached to X. Okay, now it depends where actually you see that peak and where you see it. And if it's around 13, okay, if it's around 30 or 2900, usually around 2900, that represents CH with sp3 hybridization. If it's 3100, around 3100, that's going to be sp2 hybridization. You go around 32 or higher, like between 32 and 33, that's going to be sp3 hybridization, sp1 hybridization, because it's more electronegative. And okay, NH2 versus OH, and electronegativity of oxygen is higher than electronegativity of nitrogen. So that means the OH bond is going to be shorter than NH. Okay, so OH bond is shorter than NH bond. That means the wave number for OH bond is going to be higher than the wave number for NH. Because NH is a longer bond, you will need less energy to stretch that bond or to vibrate it. And this one is going to be really broad peak. Okay. Forgive me. Okay. I'm not that good. Okay. So that's going to be the shape of OH bond. Well, when it comes to NH, it depends whether it's a primary or secondary. Usually it will be narrow or maybe two narrow peaks sitting on the top of each other. Okay. And last thing that I want to mention, okay, we use IR to go after kinetic and after kinetics of a chemical reaction, or what do you call it, like after actually finding yield. Okay, sometimes finding yield of a chemical reaction. And in this case, we have OH, and that's going to give us a broad peak around 32 to 3400, okay, in that range. And the OH, we oxidize the molecule and we turn it to a carbonyl group. And now, because we're not going to see a peak around 32 to 3400, that's OH signal, it will be gone. But instead of it, we will get this stretch CO between 16 to 1800. And if you follow this peak, or you see the constant, technically the signal is getting stronger and stronger, that means you are forming that ketone compound. Okay, so that's a way we use technically IR for the purpose of kinetics. And thank you very much. And this is going to be technically end of the chapter 11.